So one of the things we talked about when we first introduced energy is that we want to develop the skill of recognizing forms of energy and then become very good at keeping track of that energy. So the types of energy that we're going to keep track of initially, well, one type we've already introduced, that's the kinetic energy. So again, we use big K for the kinetic energy. That's the energy an object has due to its motion. The second type is potential energy. So we're going to use big U for potential energy. And this is the energy an object has due to its position, due to its location. More specifically, it's the energy a system has due to the configuration of its parts. So where each of those parts are relative to the other, that matters in terms of the potential energy. So to talk about the potential energy, we actually need to step back to talk about work. And when we set up our definition for work, we said that work was a transfer of energy due to a force acting on an object to cause or hinder some displacement. So if the force acted in the same direction as the displacement, then it was helping to cause that displacement, and that force did positive work. If the force was acting opposite the direction of the displacement, then it was acting to hinder the displacement, and that was doing negative work. Well, we can think about the work done by any force as sort of breaking things up into two categories in terms of how they're transferring energy around. So one set of forces, when they do work, they're either adding or subtracting energy from the system. So they're adding energy to the system or subtracting energy from the system so that you have a transfer of energy into or out of the system. But there's a separate set of forces that when they do work, they have the ability to convert energy from one form to another. So here they're not transferring energy into or out of the system, they're transferring energy within the system. So the total energy you have stays the same. You're just switching how it's arranged. So this first type, right, where we're adding or subtracting energy from the system, we're changing the total amount of energy we have, that requires work done by non-conservative forces. So when non-conservative forces do work on our system, they're going to act to change the total energy. But when a special set of forces called conservative forces act on our system and do work, that's not going to change the total amount of energy, but it is going to change how the energy is allocated. So it's when conservative forces do work, they're going to be able to transfer energy from kinetic to potential or from potential to kinetic. So our definition for the change in potential energy is literally that the change in potential energy is equal to negative the work done by conservative forces. So what this means is that the potential energy is trying to describe an energy that's available to a system due to its configuration. But where this energy comes from is basically the ability of a conservative force to do work. So to access that potential energy, what you've got to do is you've got to let the conservative force do work. And so when a conservative force does positive work, it's going to convert that potential energy into kinetic. So by increasing the potential energy of the system, what you're doing then is you're increasing the opportunity for a conservative force to do work. So one of the conservative forces that we'll deal with a lot is the gravitational force. The gravitational force is related, the work done by the gravitational force is related to the gravitational potential energy. You can increase the gravitational potential energy by raising an object. So an object's gravitational potential energy increases as you lift it up. So again, you've changed its position, you've changed the configuration of your system by raising your object up, which means that what you've done by putting it in a higher place is you've given the gravitational force more opportunity to do work on that object when you let it go. Right? So the higher up an object is, the more opportunity the gravitational force has to do work on the object as it pulls it back down towards the ground after you release it. So that's the idea. So clearly one of the things that's important about in thinking about potential energy is recognizing what conservative forces are out there. So in this class, which forces are conservative forces? Well, there's only two of them. So one of them we've talked about, gravitational force, that's going to be related to the gravitational potential energy. So when we see the gravitational force in our free body diagram, we know that that's going to have the possibility of changing the gravitational potential energy. The other conservative force that we'll deal with in this class is the spring force, right? So the spring force is going to be related to the elastic potential energy. So when an object is attached to a spring and it moves around, the work done by the spring force in that opportunity, as it moves around, is going to relate to how the elastic potential energy is changing. So then, what are our non-conservative forces? And basically, the short answer is everything else. Right? So for us, in the first semester, right, for 221, we're only going to have to worry about two forces: gravitational force and the elastic force. Those are the only conservative forces we have. You'll add a couple more in 222 when you start talking about an object's position in an electric field or an object's position in a magnetic field. But for us right now in 221, there's just two conservative forces. Everything else will be a non-conservative force. All right, so again, here's our definition for the change in the potential energy. It's equal to negative the work done by the conservative force. So then we want to think about whether U is increasing or decreasing. We need to think about the kind of work that the conservative force is doing. So if the object moves in the direction that the conservative force pulls on it, then the conservative force will do positive work, which means that the potential energy will decrease. So when you let an object go, right, when you're holding an object up above the ground and you let it go, our conservative force, gravity, it's pulling down on the object. Once you let it go, the object falls. So it's moving in the direction gravity wants to pull it, which means that gravity is doing positive work. So the work done by the gravitational force in that case would be positive, and you're decreasing the potential energy. On the other hand, if you move an object opposite the direction that a conservative force wants to pull on it, or the conservative force pulls on it, then the conservative force is actually doing negative work. And that negative work is effectively being stored as a potential energy. So you increase the potential energy when conservative forces do negative work. So to increase the potential energy, you have to do positive work against the conservative force. So in lifting an object up, right, you do positive work to lift the object up. Gravity does negative work under that circumstance. The negative work done by the gravitational force is what's being stored as our potential energy. So that's the idea of what our second form of energy that we need to keep track of, potential energy, is trying to indicate.